Let's talk trash.
Sun-baked plastic.
Just this one chemical, bisphenol A, that is used to make this hard, clear plastic called polycarbonate, is produced at over 7 billion pounds a year, and it's a non-recyclable plastic. We humans make waste that nature can't digest. Here is the accumulation at Ballona Creek next to the LA airport, and here is the flotsam near California State University.
Garbage on the right. Let's take a little closer look on this side.
This is the legacy we are leaving to future generations. The market can do a lot for us, but it can't fix the natural system in the ocean we've broken. All the king's horses and all the king's men will never gather up all the plastic and put the ocean back together again.
Dolphin Party, USA. Dolphin Party, coming here to play with dolphins. Jesus Christ, there's like 20. They're still coming from the distance. There's so many fucking dolphins.
No hope of cleaning it up. Straining the ocean for plastic would be beyond the budget of any country, and it might kill untold amounts of sea life in the process. The solution, Moore says, is to stop the plastic at its source.
Well, hi guys. You're going to feel pretty bad about yourselves by the time I'm done with you, after looking at what you just experienced, because you have a lot to do with it. So we're going to start with just diving right into the chapter 16. We're looking at waste generation and waste disposal. I want you to start by opening your eyes to the upper right corner. We're going to look at these two cups. One is paper, one is styrofoam. Which do you think is more environmentally friendly? Most people would say paper, but do they really know all the facts? Paper cups use trees and are usually used with even more paper, like a cardboard band wrapped around them to keep hands from getting hot or cold. This also creates more waste, although a paper cup decomposes in a landfill and is a good candidate for incineration. To produce styrofoam, we make a plastic polymer called polystyrene. It's made from petroleum, like all plastics, and it does not decompose in a landfill, and it emits toxins when incinerated. When we analyze the inputs and outputs of all energy to manufacture, use, and dispose of a product, we refer to the model as cradle to grave, or life cycle analysis. Remember those, cradle to grave and life cycle analysis. This doesn't make the decision to pick the better cup easier. For example, making one paper cup uses 2 grams of petroleum and 33 grams of wood and bark. A styrofoam cup uses 3 grams of petro, which is non-renewable. Paper cups are heavier and they cost more to transport. Paper cups use more energy to make and transport, which means more air pollution. Paper cups are usually thrown away after one use. Styrofoam, however, can be reused, but honestly, we have a throwaway society. We don't really reuse those cups, we throw them away. Styrofoam could leak chemicals into your soda or your coffee. Paper cups could leach bleach to the drinker. So where do you stand? It's hard to decide. It shouldn't be hard, We need a better system for waste generation, waste reduction, and waste disposal. Here we're looking at a detritivore. Remember this guy, the dung beetle? Detritivores, like this dung beetle, recycle the waste from animals using the energy and nourishment they obtain from them and turning the remainder into compost or topsoil. This elephant waste right here is a resource. Actually, is my little laser pointer on? There you go. Elephant dung right here. This elephant waste is a resource or source energy for other organisms. Humans are the only organisms that produced waste that others cannot use. What we no longer use in the throwaway is called refuse. Refuse collected by municipalities from households has been estimated to increase with population growth and more development and affluence. Where we're beginning to try to reduce and reuse, recycle is a little more, but small businesses and institutions such as schools, prisons, municipal buildings, and hospitals are not helping. So as a matter of fact, the two lines on this chart show the discrepancy in our waste outputs. 60% of municipal solid waste comes from residences, and 40% comes from commercial and institutional facilities. If you think about how we used to live way back in the day, we recycled all metal, wood, and glass. We just never called it recycling. If a wooden bookcase broke, we reused the wood for stool for heating. After World War II, and rapid population growth and increase in industrialization and wealth of the U.S., we purchased household conveniences that could be used and thrown away. This saves us from labor-intensive work. So we just started throwing away everything as soon as a new model was available. This planned obsolescence, the design of a product so that it will need to be replaced soon, became typical of our new throwaway society. We even started using disposable diapers and no longer reused cloth. We became the throwaway society. By the way, look at this chart. Approximately how much waste does the average person generate per day? Yep, around 2 kilograms. That's about 4.4 pounds. That's average. That's pretty bad if you calculate how much that is per year. So do you generate more or less than that per day? Do you generate more than 4.4 pounds per day or less than 4.4 pounds per day of trash? Think about everything you throw away over the course of a week. What's your daily average? Overall, we, the U.S., produce more trash than developing countries. Some indigenous people generate only 2% of municipal solid waste that gets thrown away. Even in developing societies, people scavenge and reuse discarded material. Unfortunately, much of the U.S. manufacturing discards unused waste in these other countries. The environmental costs are astounding. There is no such thing as away. When we throw anything away, it must go somewhere. That somewhere includes landfills and dumps, even the ocean. Trash builds up. You need to remember that municipal solid waste stands for MSW, municipal solid waste. Municipal, as in people and cities. Once a product is discarded, it enters the solid waste stream. The flow of solid waste that is recycled, incinerated, placed in a solid waste landfill, or disposed of in another way is part of the solid waste stream. If I took 10 random trash bags from the landfill, experts have determined the percentage of paper out of all 10 bags would be a whopping 31%. Wood comes from construction debris mostly. What's next? And next. Look how much of it is compostable. Potentially, we could just compost all of it, but we're throwing it away. Roughly 33% of current municipal solid waste could be composted. Whoa. By the way, durable goods are appliances, tires, the big stuff. Then there's e-waste, electronic waste. Televisions, computers, cell phones that contain toxic metals like mercury, cadmium, and even lead. These are relatively small by weight, but very important and rapidly increasing. These can combine with the water in the trash to form dangerous compounds. If these compounds leach into the groundwater, people get very sick. If the recycling is done without protective gear and respirators, the workers with these recyclables can become very ill. And we all know that children are in the workforce in these developed countries, and they're not being protected. Did you know that we even sent our e-waste to these developing countries where they dismantle it? That's because it actually cost us more to recycle it than to just dump it. Solid waste management is all about these three words. What is the first choice, according to scientists and economists? Reduce. Reduce is the first choice because reducing inputs is the optimal way to achieve reduction. It's also known as waste minimization and waste prevention. Source reduction is the term associated with reducing. The winner in reduction is Subaru. Subaru had zero waste going into landfills in 2009. Reuse means no energy or no additional energy or resources are needed for the object to be reused. This would be better than throw away, like our throwaway society. And then recycle, closed loop recycling of a product in the same product. Aluminum cans, metals are reused as aluminum. Can repeat again and again. Open loop recycling is like plastic bottles recycled into a jacket or a pen. No landfill, but you still need the petroleum to make the plastic bottles. The U.S. recycles 1/3 of all waste, and it's increased. Japan recycles 50% of all its waste. Then there's single stream recycling and zero sort. This is popular, but glass and paper are highly volatile markets, not always a high demand. Recycling costs lots in time, labor, and processing, money. So New York cut the glass and plastic recycling. Recycling is the last choice in the 3 R's. Did you know that 1 quart of motor oil can contaminate 2 million gallons of fresh water? We're going to compare these two pictures. You have picture A and picture B. The basic gist is the end product and how it gets recycled. I've already explained these just a few moments ago. So this is an example of closed loop recycling. So we have 2 types of recycling, and what you need to remember about closed loop is it's the recycling of a product into the same product. So like aluminum cans melted and reused as aluminum cans. We can repeat it again and again and again. And then we have open loop, plastic soda bottles recycled into something else like a jacket or pen. There's no landfill, but we still need the petroleum to make the new plastic bottles. Well, we've come a long way since the 60s. We're more conscious of recycling in our municipal waste. We're not talking about industrial here. The U.S. recycles 1/3 of all waste. Not bad, but lots of room for improvement, and it has increased. Japan recycles 50%. So here's how you interpret this chart. The blue line shows us how much waste was recycled in the U.S. over time, but the orange line is pretty telling. This line shows the percent increase from each year to the next. The percent increase seems to be declining slowly, but surely. This is a single stream recycling facility, and as I said before, single stream and zero sort is popular, but glass and paper are not always popular for recycling. So if they're not in high demand, then the recycling is going to cost a lot more in time and labor and processing and money. And so New York does not recycle these things. Recycling, remember, is the last choice. Then there's compost. Composting is really good for the earth. You can produce very fertile soil out of it. It takes about 6 weeks up to 4 months to make really good compost. Look at how easy it is. Do you have what you put in daily? Note that what not to put in. This is really important, what not to put in. So I want you to follow this next picture from the bottom up. There we go. Surely you can gather these things. You just pile it up daily, you cover it daily, and you mix it up every week or so. Just like kind of like in a landfill. You let it cook and get really hot. You'll even see the steam from the decomposers working so hard. Oh, and if you get a bunch of red worms, you just can order them for like $5 for a big box of them. They love this stuff. And they'll help mix it for you, and they'll eat it, and their castings, also known as poop, will make the soil even richer. This is a municipal composting facility. You can actually find a very similar setup at our very own county landfill, the Scarborough landfill. Sanitary landfills, They're engineered ground facilities designed to hold municipal solid waste with little contamination, or something slightly different. This is at the landfill, but this is what the composting facility looks like. So we have our waste dumped in our tipping area, and then we take our compostable materials out of it, and then material is moved that's not compostable, and then we put our compost material here, we aerate it, we turn it every once in a while, and we leave it here for a long time. You can go to the landfill every spring, and you can pick from the piles, and the real dark, rich compost soil or topsoil cost more per truckload, but you're not paying much. You're not paying much compared to what you would pay for a bag of that in Home Depot, which would be a lot. This chart shows the fate of municipal solid waste in the U.S. The majority is disposed of in landfills. So I'm going to show you a landfill video in a moment, if I can just get out of this video. Landfill, because I want you to get an idea of what a landfill looks like from a real video perspective.
Machines.
It's kind of amazing to push 20 tons of trash.
Trash piled 20 stories high.
I was a little too close to the edge, and I couldn't stop. I knew I was going down.
Man and technology in a battle against a tidal wave of waste.
It's a football field-sized area that's got to be buried every single day.
Uncover the gargantuan world of garbage at America's mega dump. Garbage. We all make it. We all hate it. Yet America produces more garbage per person than any other country on the planet. 230 million tons each year. That's heavier than 2,000 fully loaded Nimitz-class aircraft carriers. It's up to landfills to make the bulk of this mega mess disappear. And when it comes to mega, no landfill is bigger or busier than California's Puente Hills, America's largest active mega dump.
This landfill site has 100 million tons buried in place. So it's a big operation.
Just 16 miles outside Los Angeles, this megastructure covers 1,400 acres, including the dump site, the materials recovery facility, and the power plant. Each day, it consumes over 13,000 tons of municipal waste, nearly 900 tons of asphalt, more than 100,000 tons of green waste, and 700 tons of ash. There's enough garbage delivered here to fill the Rose Bowl in just 13 days. And the sights, sounds, and smells?
Stick your head in your garbage can and find out exactly how our cities would smell without these kinds of sites.
The challenge is to handle this much mess safely, and the stakes couldn't be higher. A landfill this size is a melting pot of toxic chemicals and disease. One minor mistake could pollute the groundwater and poison local communities for years to come. Here, everyday household products such as batteries, pesticides, and nail polish turn into potentially lethal cocktails.
This is a almost totally full can of paint thinner. You don't want to have to drink that.
6 a.m. The gates to Puente Hills open. The race to get rid of LA County's waste begins as hundreds of massive big rigs arrive to drop off their messy payload.
You watch the traffic controllers, they look like conductors at a concert.
destination, the dump site, and a target location called the cell. This football field-sized patch of ground is the fundamental building block of a megadump. Throughout the day, every hour, another 1,000 tons of garbage is dumped until they meet the maximum 13,200-ton limit. The objective? Smash, crunch, and cram everything into this cell until it hits capacity. It may look like chaos, but to cram all this waste into the daily cell takes planning. Here's how they do it. Trucks dump garbage in rows of piles. Next, dozers push the trash into the cell. But to maximize space, they need to minimize the garbage. Puente Hills Landfill, California, America's largest active dump. From open to close, every hour, over 2,000 tons of garbage hits the landfill floor. Each load contains a deadly cocktail of chemicals, from cleaning products to pesticides and battery acid.
Here we have nail polish, and this has 3 or 4 ingredients in it that are on the EPA's acute toxic list. And these are the kinds of things, again, it doesn't hurt you to put them on your fingernails, but you wouldn't want to drink it.
Inside the landfill, bottles break and cans rip apart. Chemicals mix together to form a toxic garbage juice called leachate. If this poisonous goop escapes into the drinking water of local communities, the results could be poisonous, carcinogenic, and possibly deadly. Each garbage load has a unique combination of chemicals. Like an uncontrolled experiment, they mix in strange combinations and quantities. The results are unpredictable.
Nobody knows how many people would get sick or how they would get sick or whatever else, because nobody knows exactly what's in that leachate.
The challenge is to make sure this toxic leachate never gets into the groundwater. Puente Hills has a 2-point battle plan. 1. Create a mega barrier. 2. Constant monitoring.
Protecting groundwater is crucially important in the Los Angeles region. We get a big part of our water supply in Los Angeles from groundwater tables.
Creating a barrier begins at ground level when the dump is built. First, construction workers dig out the shape and design of the operating area. Next, they cover the walls and floors with alternating layers of clay, sand, and drainage material. The final step, wrap the dump in plastic. This is the landfill's armor, 80 mil of polyethylene plastic. That's 80 thousandths of an inch thick.
The liner material is a very heavy plastic. It's not quite as thick as my little finger, but it's pretty heavy material, and it would take a lot to punch through it.
Engineers then lay 17 miles of perforated pipe at the bottom of the dump. These will collect any water that enters the landfill and pump it to a water treatment plant, where they will remove any toxins from the liquid.
If it's been through a cleansing process, which is something like your sewage water goes through, I've been at landfills where they've served me coffee that has been brewed with leachate.
The liner system is the main barrier between the garbage and the water table. But Puente Hills has another line of defense, the leachate monitors. Each day, they take samples from inside and outside the landfill. If there's a problem, these teams will pick it up.
We're checking to make sure that anything on the inside of the landfill is not escaping to outside.
Engineering technician Helen Francis Beda and her colleague draw a sample from a leachate collection sump below the surface.
All right, it's full this time.
Next, they test the groundwater outside the landfill. If both contain the same chemicals, a red flag goes up. The liner may be leaking. It's every landfill operator's nightmare.
You don't want to have to deal with it, because the only way to deal with it and clean it up is to dig up the whole area and put it through some processors, you're talking tens of millions of dollars.
Here at the Puente Hills Mega Dump, there's another landfill hazard that also needs monitoring: landfill gas. It all begins deep in the piles of garbage. Here, when organic materials decompose, they can create a mixture of methane and carbon dioxide, with explosive consequences for people living near the dump.
There are many, many horror stories about methane from the landfill somehow migrating to a house, to a basement, and some guy goes down in the basement and flicks his lighter, and there's a big explosion.
A mega dump like this can produce landfill gas in huge quantities, 40 million cubic feet each day. That's enough to inflate 200 Goodyear blimps. But this toxic cloud has a silver lining. Puente Hills uses the explosive power of landfill methane gas to produce enough electricity to power 100,000 homes.
I really think that methane is a tremendous plus, because it is really one of the very, very few byproducts from all of this otherwise waste that can be utilized.
So, what'd you think of all that? I have to get through a whole lot of other information, so just keep up with me. So, you just learned all about a modern landfill, a sanitary landfill. If you want to see more of that video, then just look up the National Geographic garbage dump, largest in the U.S. It is 50 minutes long. There's no way that I could have shown you the whole thing. But I do want you to notice the little truck in this picture. This is really important because that'll give you an idea of the scale of what we're looking at here. So there's the truck, and then notice the scale of the whole size of what's going on underneath the surface. So everything in this picture you've already been shown in the video. You can just pay attention to it, and then I think you'll have a much better and deeper understanding. So a little experience about that mega landfill. That's what you just experienced. It was a mega landfill. The Scarborough landfill is not a mega landfill, but they do all the same things. So sanitary landfills are engineered ground facilities, and they're designed to hold municipal solid waste with as little contamination of the surrounding environment as possible. Leachate, look on this diagram so you can follow me. Leachate, the water that leaches through the solid waste and removes various chemical compounds with which it comes into contact, is what we're very, very concerned about. Landfills are at risk of harmful runoff and leachate. So the removal of harmful chemicals from the municipal solid waste is always a challenge. Landfills can harm aquifers, rivers, streams, drinking water, human habitation, but we use sanitary landfills for most counties. It's constructed with clay or a plastic lining at the bottom, which you learned about when you watched the video. The clay impedes the water flow, and it retains positively charged ions such as metals. Eek. Pipes collect this leachate, and the leachate is from anaerobic digestion. Remember that part. The leachate comes from anaerobic digestion. Okay, that's what it comes from. So a cap is usually what they put over the landfill. Every day they have to put a cap over it. So they put a cap over it. It's made of soil and clay, and when the landfill reaches capacity, they put a permanent cap all over it. 54% of all municipal solid waste goes into a landfill. That's pretty bad. The only things that should go into a landfill are composite materials that will not harm the environment. All organic materials, such as food scraps, are sources of methane, which is why we should compost them instead. That's a bad thing. Keep in mind that when you get your trash collected, you are paying towards the tipping fees. Tipping fees are truckloads. It's usually $35 per ton. And if we pay, then we're a little more encouraged to recycle because we don't like paying that money. If it's too much, that if they charge us too much in the tipping fees, then they already know from research people are going to tend to waste more. So the site of the landfill is controversial. Who wants in? You don't want it in your backyard. It's an environmental justice issue. Environmental waste management or integrated waste management is source reduction, recycle compost, less municipal solid waste, less in the landfill. This is all a connection of the dots. Some landfills have methane extraction, which is what you watched. Once capped, the landfill can be reclaimed. Reclaimed landfills can be playgrounds or parks. Just note how big a system like this is. Look at the scale of the landfill compared to that truck and the leachate. Ugh. But also notice that if there's a leak, we're not going to be able to fix it easily without going all the way to the underground system, digging everything up. Then we have to find it, because the leak is only determined by the well monitor. Okay. The site of a landfill is controversial, so who wants in? Do you want a landfill in your backyard? Do you want it in your neighborhood? NMBY, not in my backyard. It's an environmental justice issue. More and more communities consider the NIMBY activism and have developed a solution called integrated waste management. This is where you use source reduction, you recycle compost, you have less municipal solid waste, less in the landfill. And that's what it looks like when you have activists trying to fight for your rights and for your freedom. Not in my backyard. Now let's take a look at other ways to dispose of our refuse. Incineration is pretty popular because you put less into the landfill. It's less volume. Note that you do still put ash from whatever you burned into the landfill. Sometimes we use these trash incinerators to generate steam to energy, or we even reuse the heat. This would be a waste-to-energy plant. Incinerators are ideal for waste that is paper, plastic, food, and yard scraps. That's what they're good for. But if it's other waste, we get sulfur dioxides, nitrogen dioxides, and toxic metals even in the air. Usually we can minimize these with filters, but those make them less efficient, and they're not foolproof. They don't protect us from everything. So here's how it works. We have paper, plastic, food, and yard waste. These are the excellent candidates. We also have all our other crap that we put in there. Heat's released, and the CO2 and the water in the atmosphere combines with it. Particulates in the ash. We have two different types of ash from an incinerator. We have fly ash, and we have bottom ash. Ash goes into the landfill if it's bottom ash. Ash is more concentrated and is more toxic than landfill waste. It is much more toxic. This ash is much more toxic than the ash from landfill. Well, we don't get ash from landfill because we're not burning it. Ash is metals and it's toxic stuff, but we use scrubbers. We put them right in here somewhere in the stacks, and that helps neutralize the acids. So sulfur dioxides and acids are released. Leachates are released. There's a great deal of heat energy, though, that we can get from incineration of our trash. We can take advantage of that, and we do more and more now by constructing waste-to-energy systems. It costs a whole lot of money. You're not going to see something like that in a developing country or even in a community that doesn't have a lot of money. So it does produce energy. You do have tipping fees. So even though I said the tipping fees might be, an average of $35 per ton, here in an incinerator, it's $70 per ton. Not in my backyard. Incinerators need more trash to be energy efficient. So they discourage the recycling. They actually want you to put everything in there. There's many pros and cons to landfills and to incinerators. Only some are listed here. It's a tough choice, but some are better depending on the community type, the geography, the hydrology of the land, and the number of people and the amount of space that you're dealing with. All right, last part, I'm almost done, with hazardous waste. Hazardous waste is liquid, solid, gaseous, or sludge waste material that is harmful to humans or ecosystems. There's over 20,000 hazardous waste generators in the United States, according to the Environmental Protection Agency. It's mostly a byproduct of industrial processes, but even car service stations, like to do oil changes, and dry cleaners, they generate very hazardous waste. So we could put some legislation into place by protecting us, by monitoring, regulating the hazardous waste. The EPA requires that we treat it before we dispose of it by making it less environmentally harmful. Bring your toxic stuff to a special collection site each year so that your toxic wastes don't eventually come back and haunt you in the water you swim in, fish in, or drink. Regulation and oversight of hazardous waste falls under two pieces of federal legislation: the United States Resource Conservation and Recovery Act, also known as the RCRA, and the Comprehensive Environmental Response Compensation and Liability Act, CERCLA. Find that on the screen. CERCLA is also referred to as the Superfund Act. You need to know about the Superfund Act. The name of this is based on a fund. The government taxes companies in advance to make sure that hazardous waste is tracked and properly disposed of all over. They specifically tax oil and chemical companies extra, but they use that tax to clean up older and abandoned hazardous contaminated sites. The HSWA, the Hazardous and Solid Waste and Amendments of 1984, even phased out the disposal of hazardous waste on land. So we're not even allowed to dispose it on land anymore. This is a typical picture that you see around Superfund sites. There's one just like this, right on APG. Under the Superfund CERCLA Act, the EPA maintains the National Priorities List, or NPLs, which is shown on this map. It shows contaminant sites that are eligible for cleanup funds. We have one site in our country on APG, and a Superfund site of our very own, right here, our county, not country, sorry. As of 2010, there were over 1,200 Superfund sites on the National Priorities List. New Jersey actually has the highest number of Superfund sites, 114. An interesting story you should watch a video on is on the case study of the Love Canal in New York. It became the best known story of hazardous waste that harms many residents. They filled in and topped a landfill. So this was before there were rules to protect the groundwater from landfills. And then a site that was just developing on the land just took over the landfill. They filled it in. They put homes on it. They put playgrounds in it. People bought the homes. People and children got sick. They found incredibly toxic soil. They found very toxic water. Voila, history's made. It was a Superfund site, a threat to human health. It was finally taken off the National Priorities List in 1994. We do know the CERCLA does not have enough funds to clean up all abandoned and financially defunct sites, so human health is still at risk from Superfund sites. You also need to know about brownfields. Brownfields are also contaminated sites. They're like Superfunds. They're contaminated by industrial or commercial waste that may require environmental cleanup before they can be redeveloped or expanded, but it's not as severe as a Superfund site. The EPA has a brownfields program to encourage investors to get a great financial break to clean up and revitalize a brownfield contaminated site. They're not as carefully monitored, and they could still pose human health risks. We have some in Maryland, but they're not easy to find as the EPA does not disclose all the brownfield sites to protect people that live in the neighborhoods of them. So pause if you need to review all this information, because I'm going to keep going. You know where to find this video. The process of making an objective assessment of solid waste disposal options is tricky. This process is known as the life cycle analysis. Life cycle analysis is an important system that looks at the materials used and released throughout the lifetime of a product, from the procurement of raw materials through their manufacture use, and then to look at its disposal. That's why it's also called cradle-to-grave analysis. Life cycle analysis, also cradle-to-grave analysis, should include all the other externalities we have learned about previously in this class. Waste disposal choices aren't easy. They're influenced by economic as well as scientific choices. A more holistic approach is called cradle to cradle, and this method is not embraced by all, and that's to develop as many options as possible, emphasizing reduced environmental harm and costs. This is integrated waste management, which employs several waste reduction management and disposal strategies in order to reduce the environmental impact of municipal solid waste. Here, if you follow the arrows, oops, I missed the arrows. If you follow the arrows, they indicate the waste stream from manufacture to disposal of to disposal. And if you look at the curved arrows, they indicate ways in which waste can either be reduced or removed from the stream, thereby reducing the amount of waste incinerated or placed in landfills. So about this cradle-to-cradle perspective, where we minimize waste generation before, during, and after manufacturing, we think about how to reduce and recycle all parts before we even start manufacturing. Like we think about it going right in. That's good stuff, I think. Well, we have lots of options on how to handle our waste and source reduction. We still have to generate less waste. We have a long way to go. It's up to you. You can be the one to change public and societal attitudes towards protecting our human habitat. Make less waste. This is the end of the chapter lecture on municipal and hazardous solid waste, and use it up, wear it out, make it do, or do without. This is Mrs. Gabriel, signing off.